Okay, your assignment for last night was to do the worksheet 16 and this quiz preview. So hopefully you're just checking if you know what you're doing. If you want to work on something else while I go over these, just make sure you're checking that you have the correct answers. There's several ways that you could look at this problem in order to decide how to figure these things out. One, you could look in your graphing calculator. Two, you could write it as an exponential, which would be 10 to the y equals x minus 4. Okay. The inverse of this would switch the x and the y. Then, for one thing, I mean, I'm just trying to make you understand that this is actually, oops, I meant to write plus 4 first. I don't know why I'm doing this, but I am. I'm just reminding you that the logarithms and the exponential functions are inverses of one another. So if you were doing this problem and you put in 0, you would get 5. 10 to the 0 is 1. 1 plus 4 is 5. So the 0.15 would be on the inverse functions graph. And that, remember, those were the graphs of the exponentials went like that. What do the logarithmics do? They switch the x and the y's. And I just plotted that in the wrong, no, it was 1,5. Okay, so this was 1, actually I put in 0, and I plotted that in the wrong place. Sorry about that. Okay, then the inverse would have the point on it, so I'm going to get rid of that. Sorry, 0,5. The inverse function would have the point on it that is the switch the x and the y. So instead of 0,5, it would have the point 1, 2, 3, 4, 5, 0 on it. And it would go like that. Remember that the inverse is a reflection over the line y equals x. All right, so the x-intercept for this function is actually 5, 0. Now, I'm going to explain it a completely different way. If you were to rewrite this as an exponential, or if you put in 0 for y, 0 equals the log in base, that is base 10 understood, since there is no, that's a common logarithm and there's no base written down here. So you could have just solved it like this, and this I think is much easier, but I wanted to relate it back that these what inverse functions were. So this is 10 base, the exponent would be 0, 10 to the 0 equals x minus 4. You would get 1 equals x minus 4, and you would get 5 for x. So bang, there's the x-intercept. So I could have I explained it two different ways. One, looking at the inverse, because I think a lot of you understand graphing and the exponential functions better than the logarithmic. But I just proved it that this is the x-intercept. The domain of a logarithmic function, this is your log function. This is the one that's y equals log x minus 4. The domain is from 0 to infinity, non-inclusive of 0, and the range is infinity, negative infinity to infinity. Okay, these would be flopped if you were talking about the exponential function. Okay, rewrite the following in either logarithmic or exponential form. What your rule is that you're supposed to know is the definition of a logarithm. I like to start with the exponential. If b to the x equals y, then the log in base b of y equals x. So rewriting, that's how you go back and forth. So this would be a base of 2. 2 to what? To rewrite this, it'd be 2 to the x equals 64. That's the exponential equivalent. This would be the log in base 7 of y equals 3. Any questions up through number 3? All right. Evaluate. Now we're saying to ourselves, 4 to what power is 16? The answer is 2. If you give me this on the quiz, and that's all you show me, I'm not going to accept that. This is not the answer. This is how you think about the answer. The answer is simply 2. Okay, so do not do this and expect that for the... What's the matter? Go ahead, Scott. this? Oh no, I would say in my head 3 to what power is 81, and I'd write 4. Yeah, I'd say 2 to what power is 1/4? -2. I was just explaining them. Okay, 9 to what power is 1? 0. So if you know those, boom, 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 just write them. This is how you think it out if you're, I mean, that's what I was thinking in my brain. Okay. Does anybody need me to write more about those 3? Or do you want to talk about 6 or any of those more in more detail? I don't mind. No? Okay. So to answer your question, no. I want these answers, period. Right? That's scratch work. Find the inverse of the equation. All right. This is a logarithmic. The inverse of it is to be an exponential. So first step, switch x and y. You don't have to do that first, but I'm going to, because that's kind of the pattern we followed when we did our inverses. Then rewrite it as an exponential, so y will equal, and I can put that in my answer blank, y is going to equal the base of 5 to the exponent x. Questions about that? Okay, the other way you could do it is first just rewrite this as an exponential, 5 to the y equals x, and then switch the x and the y. Okay. Expand the expression. We're going to be using our logarithm rules. So rules that you're supposed to know, the log in base b of x times y is equal to the log in base b of x plus the log in base b of y. You also are supposed to know that the log in base b of x divided by y equals the log in base b minus, the log in base b of x minus the log in base b of y. And the other one was the log in base b of x to the n equals n times the log in base b of x. Okay, those are the 3 rules that we learned recently. So that's the quotient rule here, product rule, and the power rule. So this would be log of 2 plus log of w plus log of z. This one would be log of 5 plus log of m minus the log of p. Yes? Questions about 9 or 10? Okay, the next one, you have products and powers. I'm going to take more steps on this one. The natural log of x to the -2 plus the natural log of y to the 3rd minus the natural log of w to the 4th. And then rewrite by putting the exponents out front using the power rule. So -2 times the natural log of x plus 3 times the natural log of y minus 4 times the natural log of w. Okay. That would be the fully expanded answer. Questions? Does anybody still need this page? No. All right. Condense. Now we're going to use the rules in reverse. We're going to put the 2 back on as an exponent. And we have a sum, so we're going to multiply. So this would be the log of y squared plus log of 4. And then condense down log of 4y squared. And technically that should be in the parentheses. If it's not really wrong, but it's really important if you have something being added or subtracted after that to have the parentheses. Okay, number 13, put these back on. Natural log of a to the 3rd minus the natural log of b to the 7th. You have subtraction, so you I don't know what that was, why it has a double A, but there we go, ln. The natural log of a to the 3rd divided by b to the 7th. In this one, natural log of 4 to the 1/2 times, okay, it's okay if I do this all at once? Yes. No. No, no, no. Good question. Okay. I was asked just now for recording purposes or anybody in the room that didn't hear. Would it be all right to have the natural log of a to the third over the natural log of b to the seventh? No. Okay, that is very, very different. Now, where you might be getting that from was yesterday when we were solving the equations, and I said, say you were solving ln of 3, oh wait, let me just do, I'm going to explain why that's not okay. All right, because we're condensing it into one logarithm using the log rules. So that does not, that you would be having two logarithms then, one on the bottom, one on the top. Now, where you might be seeing that from is when we were solving this, say it had, I don't know, I'm trying to make something up and I'm not doing a very good job of doing a perfect problem. But anyway, say that this was not part of the natural log and you needed to divide by the natural log of 3, that's very different. And then I told you yesterday that this cannot be simplified. You have to type natural log of 40 divided by natural log of 3. Okay? So that's very different than this when we're condensing it. All right? The condensing them down or simplifying the expression would lend itself to one logarithm. So never write 2 in one of those. Okay? I guess I overkilled that. All right, I've got plus here, so it's going to be multiply times 2 to the 5th. And then divide would be next by 7. Okay, 1 logarithm. Now, I could do a little more work on this. What's 4 to the 1/2 mean? Means the square root of 4. Okay, so that's 2. 2 to the 5th is 32. 2 times 32 is 64. So you actually have the natural log of 64 over 7. Okay? 15. When looking at this function, now it says to look at it. It doesn't say to graph it. Doesn't mean go look at it in the calculator and see what you see. No, no. When you look at this function and you look at the format, remember this form? Y equals a times b to the x. Okay. B is the growth factor. This growth factor says 1/4. You might think it's decay, but then you realize, oh, it's not a positive x, it's a negative x. So you want to justify your answer, and here's what I'm expecting. Anything less tomorrow, I'm going to take off. A lot of you wrote, it's growth because the exponent's negative. And I said, no, that's not right. Because it depends on this b value, whether it's growth or decay. Okay? So, what is this one? It's actually growth. And to explain it, it's because 1/4 to the negative x. Oh, I get my pen to stay still there. Okay, great. 1/4 to the negative x is equivalent to 1/4 to the negative 1. Right, made my parenthesis too soon. Oopsie. 1/4 to the negative 1 to the x. You can separate that. 1/4 to the negative 1 is actually 4. So this is actually 4 to the x power. So the b value, or the growth factor, you don't have to write both these things. I need at least the b value. I'm sure most of you will write that, which is called the growth factor, is greater than 1. Or if you wrote b is greater than 1, so it's growth. No, you could say 4 to the x, so b is greater than 1, which is growth. Something like that, all right? But you got to show this, all right? The why? Correct. You can't just write b is bigger than 1. Show me why. Here's the reason. Well, what if somebody write, what if it says 16 and then there was 4 to the negative x? What are you going to tell me? It's not growth now. That one would be decay because 4 to the negative 1 is 1/4 and the b value is less than 1. It's between 0 and 1. Okay? Give a decent explanation. Somebody knows what you're talking about. Right. Graph the function, at least 2 ordered pairs and correct end behavior. All right. This is just an exponential function. The -4 is a vertical shift. You don't have to write that down. It didn't ask for it, but I'm saying you might want to note it just for your studying. That's a vertical shift of down 4. Okay, so what happens? Well, this exponential function generally has an asymptote of the x-axis. So that's going to shift it down 4. You need to show the asymptote in your graph, else you're getting something taken off. It has to have a dashed line there. All right? Because some of you kept trying to put points on there. There's no points on that line. It doesn't touch it. You cannot put points on here. I don't care what your calculator says. And the reason it says it is it gets so close to -4 that there will be points in the graphing calculator's table that say -4. But that's what it's approaching. It's not what it actually equals. It's getting so close it rounds it. All right, what can you put in? Well, the domain's -infinity, infinity, because you can put anything you want in for x, positive or negative. I'm going to put in negative, -1, because that'll flip over the 1/2. And I'll have 2 minus 4, which is -2. So I've got a point, -1, -2. Now I'll put in -2. And I get 1/2 to the second. Well, 2 to the second, not 1/2 to the -2, would be 2 to the second, which is 4. And 4 minus 4 is 0. So -2, 0 is a point. Okay. Yeah, I did that right? All right. So I got 2 points just now, so you can go ahead and graph it. That's your minimum number, but oh, wait a minute. I'd like to put in 0 because I like to get the y-intercept. So if I put in 0 in here, I'm going to have 1 minus 4, which is -3. And now I found the y-intercept. And then I go along there. I don't cross it. Don't cross the asymptote of -4. The range is from -4 then to infinity. Okay. Of course, next we'll have to graph a logarithmic. All right, so this one, that is a horizontal shift right 2. And a vertical up 1. Now, what I think is easier for you to do is to say, well, what's the parent graph of that? And then shift it. So the parent graph would be the y equals the log of x. So I'm going to think about points on that, and then I'm going to shift them. Okay, because I think that's probably the easiest way for most of you to do the problem. How do I find points for this one? Well, I would think of this as 10 to the y equals x. Rewritten exponentially is its equivalent form in an exponential form. So then I say, well, I got to put in stuff for y. So I'm going to put in 0 for y, and that would give me 1 for x. I'm going to put in 1 for y, and that's going to give me 10 for x. So if I say, okay, the parent function has a point 1, 0, but I got to shift this right 2 up 1. So it's going to go to here, so actually 3, 1. Okay, right 2 up 1. You can add 2 to the x value. You can add 1 to the y value. So this would be 12, 2, the next one. And I'd have to estimate where that is because we don't have it on the picture. Okay, what else do you think was critical to put in here? If it's shifted to the right 2. Most logarithms have the y-axis as an asymptote, right? Okay, so that's going to shift right 2 as well. So you need a vertical line dashed at 2. That horizontal asymptote, that vertical asymptote shifted right 2. So then you're going to show that your graph runs along that, crosses through here. This, you won't be able to see this well on your calculator, just saying. And then you're supposed to try to hit your points. Oh, I didn't do a very good job. All right, the domain of this one is from 2 to infinity. Doesn't include 2. And the range is negative infinity to infinity. If you didn't do it this way, I can suggest another way to start the problem if you feel you need it. Does anybody need a different way where you exponentiate this right away? No? Do the parent graph and shift it. That'll probably be easier. All right, I'll move on. If f of x, there's supposed to be an x here, guys, on the 6. That was a typo. Sorry, that's a typo. You're like, oh, how am I supposed to answer that without that? This would be a horizontal shift. And it's going to go, since it says +2, it's going to go the opposite direction, left 2. And vertically, and a vertical shift, down 4. What a weird word, down. Okay. That's it. Any questions? Okay, 19, a scientist estimates that a specimen begins with 1,000 bacteria. That would be your amount, your initial amount. I don't know, they said use this. And then it says the A equals, most of what they're doing here is they're saying that's your A. I don't like how they wrote A there, but anyway. A, your amount you start with is 1,000. If the specimen grows by 12%, that'd be 0.12 for your R value. Every minute, write an equation that represents the bacteria's growth. Then calculate how many minutes pass before the population reaches 1,800. All right, so the amount of bacteria that you have, Y or A, whatever you want to call it, would be 1,000 times 1 plus 0.12, because it's increasing to the T, or X. If you wrote an X, that's fine. If you want to figure out when the population is going to reach 1,800, we have learned now how to solve this algebraically. Or you can put it in the grapher. So if you want to put this in Y1 and then in Y2, put 1,800, find the intersection. That would be one quick way to do it. All right, so Y equals, I already have it in there. Zoom 0, which is zoom fit. And then it intersects here, so we're going to hit second trace, choice 5, enter, enter, enter. And I got 5.18, so about 5.2 minutes. Don't forget to label with the time units. Matters whether it's years or minutes or hours. Okay, did anybody try solving it like this without using the graphers? You don't have one of these fancy calcs at home. You don't have the app. How would we solve it? Divide by 1,000. What's 1,800 divided by 1,000? Isn't it 1.8? Okay. Then you would have 1 plus 0.12t. How do you solve for exponents? You use logarithms. Okay, so you take the log of both sides, or the ln. I'm just doing ln because it's easier to write. Then you put the t out front. 1 plus 0.12 is a number. You can type that on your calculator. So you could type ln of 1.8 divided by the natural log of 1.12. Natural log, and I just did natural log. If you can do natural log, or you can do the logarithm, divided by the ln of 1.12. And there you go, 5.18, exact same answer we got moments ago. Oh, I was looking at the wrong thing. Did it work on the calculator to get out of the graphing? I was still in the graphing mode. I typed it in though. ln 1.8. Oh, I put a 5. You have to close that parenthesis up. Divided by the natural log of 1.12. Well, there's the exact same answer. Okay, I wasn't lying. All right, moving on. Suppose you invest your birthday money in an account paying 3% interest compounded monthly. That's 0.03 for your R. And use your calculator's table or graphing function to determine how long it's going to take for your money to double. All right. How much money did you get? I don't know. Grandma gave you $1. Gave you $1. $1. All right, bummer. All right, yeah. No. You can put, you want your grandma to give you 200? I'm just kidding. So it doesn't matter what number you put in for your P, because if it's doubling, it doesn't matter because you're going to double it then, and you can find the intersection no matter how much you put in. Okay? So if you used 1 or whatever you choose to use, 1 plus, what was it? How often was it compounding? Monthly? So N is 12. And then you got that to the 12T. So if this is your equation, what you would put in you actually can put 3 here. Oh, doubling, sorry, 2. It's not wrong to write this. Okay. However, that's not what you're going to put in your calculator, though. So if you're going to use the calculator to find the intersection, then you're actually going to put in this in Y1, right? Or A, Y1. And then in Y2, put 2 and then find the intersection. Or I'm going to do it algebraically while you guys go and graph it. So if you do it algebraically, you put 2 in for A. Okay, you take the natural log or log of both sides, which is what we were learning yesterday. So I'm not saying I'm expecting you to necessarily do them this way, but that's what you're going to be doing on your homework. And then you'll bring the 12T out front. $12T times, using your power rule, 1 plus 0.03 divided by 12. So then what you would need to do is divide natural log by 12. And then you'd have to divide by this. Okay, so you guys go for it. Natural log of 2. I'm going to do it on the calculator without using the grapher. See if we get the same answer. Divided by, what was that rate? And it's 1 plus 0.03 divided by 12, right? Okay. Did you get? Oh, I think I typed something wrong. Pooh. I definitely typed something wrong. Well, then let's just do it by the method we're supposed to know at this point in the unit, which was the graphing calculator method. I typed something wrong, so it's my bad. I don't want to mess with it now because that's actually the lesson you're going to be working on after the quiz. I got doubles in 23.1 years. Are you good? 23.1 years, yeah. Anybody need me to go in the grapher and show how to do it? Yes? Oh, that's fine. I would take that. Hundredth, I would never go less than the 10th. I would always go at least to the 10th, usually the hundredths. Yes, ma'am. Compounded every month, that's 12 times per year. Since time here is in years, you need to do 12 times per year. N would be 12. So if it said semi-annually, that's twice per year. Quarterly, 4. Yes, ma'am. Yes, it is. Yep. These kind of problems for these investment problems or money growth, they're years. They have to tell you something in there. that if it's that if it wasn't in years, they would have to specify that. All right, solve each equation for x. All right, so I would do these by thinking about powers of 5, because you can rewrite in base 5. So 5 to the x equals 1/25. What exponent do you have to put on there to get it to be a reciprocal and squared? So x would be -2. These I'd rewrite in base 3. 9 is 3 to the second. This can be solved by taking the log of both sides, but that was yesterday's lesson, so I'm not going to go there. So this would be 3 to the third to the 3x plus 2. All right, you can drop the bases now and do 2 times 2x minus 1, which would be 4x minus 2, and then distribute on the right, 9x plus 6. Subtract 4x and subtract 6, you get -8, and then you divide by 5. -8/5 should be your solution. If you did it by taking the log of both sides, it'd be still -1 point, and it'd come out a decimal, -1.6. Anybody still need this? All right, solve the equation. All right, it says round your answer to the nearest hundredths if needed. This one you have log of 2 to what power is 64? X would equal 6. X squared is 49. You rewrite it exponentially. Take the square root, x is 7. I omitted the -7 because you can't have a base that's negative. Questions there? Enough? All right. Evaluate. Oh, 9, 3. Do I need to explain? Yes? Okay. Well, a couple of ways I could do this. 2 to what power is 2 to the 9th? All right. This one, rewrite as a logarithm. Log in base 8 of something, the blank, is equal to the exponent log in base 8 of 3. What has to fill in to make it match? 3. Okay, we had some identities. The log in base b of b to the x equals x. That was the rule. And log in base b of 1 was 0. That was another one. Okay, then this one was b to the log in base b of x will equal x. Okay, so these are all rules we should know. Does anybody still want this? No? Okay. 26, solve for x by showing all work. If you have the same logarithm on both sides and they're both singular, you may drop the logs and solve algebraically. We've got 4x minus 4 equals 48 minus 8x. Add 8x to both sides, add 4 to both sides, and then divide 52 by 12 and reduce. Both divisible by 4, that'd be 13 thirds. Same thing on this one, the bases match on the logarithms, and they're singular logarithms to drop the logs. And watch your toes. Set to 0, factor, solve, and check your solutions. Do they work? Original problem is, I'm only worried about the -1 because I see 5 would be fine. -3, oh, -3 squared is 9. That'd be 9 minus 6. That's okay. -12 plus 15, that's positive, so it's good. Both of those answers are good. Is that the last one? There was something I did not see in here that I want you to know is actually on the quiz. And that would be PERT. You know what I mean by PERT? I think I forgot to hit. You'll have to do one with y equals p times e to the RT. Is that good enough to say, or should we do an example? Do an example? Let's see if it's in here. Because when I did the review with my second hour, I had added it in a couple of years ago, and I must have opened up the wrong one. You go here and see if that's the one. You got plenty of time. Okay, nice and slow. I should have written that down. The book pages, all those worksheets, everything except for what you picked up today. Well, let me, hold on, I'll probably try to write that down. I'm trying to find, okay, this is what I was referring to. You will have a question with the P is equal to, well, amount in your account equal to principal times e to the r times t. You can use the graph or you can solve it. So this is an example, since you're asking me also what is on the homework check. I'll let you guys just look at this, and I'm going to stop recording. So this is on the quiz. Hold on, I'll get it back for you.